So you got two homework questions due tonight, which is 4.3 and 4.4. We'll continue with chapter 5. So it'll be 5.1 to 5.6, I believe. And then we do one last section, which is chapter 9.1. And then you will have test number 2. So your test number 2 is, coming up soon, as you can tell that we are in chapter 5. So test number 2 will consist of the conic section 4.3 and 4.4. And then the whole chapter 5, 5.1 to 5.5, and then 9.1. So there are like 7, 8 sections over there. So once we finish this whole chapter 5, you will have your next test, test number 2. So including conic sections, which I will provide you that formula, and then the log and exponents that we're talking about now. Okay. So today we're going to talk about how we graph exponents and log functions. So this is mostly all the graphing piece is the big points in your test. So as I mentioned last time on the last Zoom, when you do the conic section, that's a 10-12 points where you need to do the completing the squares and find the vertices and the center and all those goodies, and then draw me the graph. That is a lot of points. And then another big point here is to how we draw the exponents and log graph or log functions graph using transformation. So some of you might not remember the transformations that we have, or so I'm going to show you what kind of transformations that we're going to use here. So example will be looks like this. This is what you will get in my test. I won't call you to draw 2 graphs. I will call you to draw 1. So I want you to draw the g of x graph. But usually when you draw the g of x graph, you have to draw the parent function, we call it, or the original function. So if you see 10 to the x here, so the 10 to the x is what we call as your original function or the parent function. If you see ex, that means ex will be your original function in this case. Same thing happens when we talk about log functions. If I want you to graph like this, then log 5x will be your original function, and log 4x. So anything you see down here like log 4 and log 5, that is what we call as your original function in this case. So so you have to graph that first before we perform your transformation. So so that's why we call user transformation. So I'm going to show you how the transformation works. This is very, very important. Please understand this. This is so important here. So please note this is what's the meaning when I say using transformation? Using transformation here means that I'm talking about translation. So translation means we move the graph. So once we graph the original graph, like the 10x, 2x, 3x, then we begin to move it up, move it down, move it left, move it right, reflect, and do all those things. So let's say that your original graph is ax. Okay. Again, a is any number you want. It can be fraction as long as it is not 0, and as long as it's greater, as long as a in this case is greater than 0, and a in this case cannot be 1. So a can be any number you want from positive to negative. So for only positive numbers. So the transformation we have here is we're going to go up, up. So how do we know if it goes up? You add a number. Okay, so you add a number, it consider goes up. So for example, in this case will be like I'm not going to use f, I'm going to use g here. So example in this case is g of x is 3x plus 5. Okay, again, the 3 to the power of x is the original function. The plus 5 means you go up 5. Sometimes they can be tricky. They can write this as 5 plus 3x. So so they put the 5 to the front. So this again, you can put the 5 at the front and put the 5 at the back. As long as the 5 is a positive, it moves up. The transformation is moved down if you subtract. So if you minus k, okay. For example, in this case is gx equals to 3x minus 2. Or if I want to move it up front, it will be negative 2 plus 3x. So they are the same thing, okay? They're just tricky, okay? So this is this number 5 and negative 2, it means you go up and down, okay? The next transformation we can have is left. So in order for us to know if your function, your exponents is moving to the left, your number is on the top of the power, okay? And it is positive. So a lot of people, if you think about coordinate system, plus means you go to the right, minus you go to the left. But for this case, if you have a plus sign, it moves to the left. For example, in this case, it will be like 3x plus 5. So the plus 5 on the top. So you need to know the difference between if I have a plus 5 like this on the base, or plus 5 on the exponents, because this is up, this is go to your left. If you know if a function is going, if your transformation is going to the right, then it's going to be minus. Okay. For example, will be like 4x minus 2. So it's not necessary always to be 3x. It can be 4x, 5x. Like this question gives you 10x. So it's always it can be any power to the x. Okay, so that is called a base. Okay. So this is the left and right. We can also do reflections on the x-axis. What is the meaning when I say reflections on the x-axis? It means that your graph will be reflected on the x-axis. So for example, in this case is if your graph is going, because it's exponents graph. So this is your original exponents graph that is exponentially a growth. So if you want to reflect this on the x-axis, it will be the orange one. So that is the meaning of reflection on x-axis. You just go the opposite direction, up, going up or down, depends on what we have here. How do we know this is reflections on the x-axis? Is you get a negative in front of your function. So example will be if I give you g of x equals to a negative 3x, or I can say g of x is negative ex. So the negative in front of it means we have reflection on the x-axis. We can also do a reflection on the y-axis. So short form is ry. This is where your negative is on the power on the exponent side. So be careful with the x and y axis here because the difference here is the negative is on the power for the y-axis, x-axis is on in the front. And what happens if you reflect this on the y-axis? So let's say the orange one that we did here is a reflection on the x-axis. So if you have the red one and you reflect this on the y-axis, it's going to be exponentially decay. So this green one is the reflections on the y-axis. So you need to know the difference between the y-axis. Usually you flip it left to right or right to left. Reflection on x-axis usually go up or down. Okay, and if you have both, yes, you can have both. So in order for you to have both, you can have both. In order for you to get both is you got negative on both sides. So you will get negative a, negative x. Okay. So if you have this, means you will have both reflection on the x and both reflection on the y. So so it will look something like negative 3, negative x. Okay. So if you have both reflection, then your graph will look like purple. So you take this at either the green one or the orange one, and you reflect it, so you will get something like this. So the orange one is the purple one is where you will have reflections on both the x and the y axis. Okay, so this is all the transformation that you kind of need to pick it up here. Okay, if you multiply, so we have addition and subtraction. So if you multiply, we call that as vertical stretch or compress. So in order for you to have a vertical stretch means you stretch it vertically. What happened is that you will get a number, let's say BAX. That means you multiply this with this number, but this number has to be greater than 1. For example, in this case, will be like 2 times 3 to the x. So the 2 in front here is what we call as a vertical stretch. That means that all your x value is double. So when you see the 2 times, means all your x values will be double. Not x, sorry, your y. All your y value will be double. So initially, this one is at 1. So it will be at 2 now. So everything will be double up. Okay. What happens if your b is between 0 and 1? Then we don't have a vertical stretch. We will have a vertical shrink. Or sometimes your book use vertical compress. So that is only happens if your b is less in between 0 and 1, like a fraction, like 1/3 times 3x. So if you have if your b here is multiplied by the exponents, and that is a fraction like 1/2, 1/3, 0.3, 0.2 between 0 and 1, we will have a vertical stretch. And when you do vertical stretch, your y value will be affected. So example is the 2 means you double, the 1/3 means you cut it by a third, you divide by 3, your y value. The last transformation we have in this case is the horizontal stretch. So vertical means you go up, down. Horizontal means you go sideways, left and right. So in order for us to know that if it's a horizontal stretch, then your multiplier is on top. That means on the power. Okay. And the stretch is you flip your condition here, means that your b in this case is between 0 and 1. For example, in this case will be gx equals to 3 to the power of 1/2 x. So as long as this half is on the power, on the exponents, and is between 0 and 1, then we have a horizontal stretch. For the horizontal shrink or horizontal compress, then the b in this case will be greater than 1. For example, will be g of x in this case will be 3 times 2 to the power of 2x. So this 2 is a horizontal shrink or compress. So when you do a horizontal shrink and compress, it will affect your x value. Okay. Now remember last time when I do a vertical stretch or shrink, I call you to do what you say. If it's 2, you multiply by 2, right? If it's 1/3, you divide by 1/3. But this one, you do the opposite. Opposite in this case means that if you see 1/2 here, means your x value is double. If you see 2 here, means your x value is cut by half. So this is very special for the horizontal stretch and shrink. Your x value is not the same as, oh, 1/2, I cut it by half. Oh, 2x, I double. No, this is actually do the opposite of what it is. So half means you double, 2 means you cut it by half. So make sure that is just very special here. So so you can have up to 1, 2, 3, 4, 5, 6 transformation here. So how do we know which one go first? You have to follow the orders of operation. Means you have to follow PEMDAS. You guys know PEMDAS, right? parentheses, exponents, multiply, divide, addition, subtraction. So that means addition, subtraction, which is this one, is always last. Okay, this follow is always last. Okay, because you add and subtract is always last. This is not last, is because this is in your exponent. So exponent is actually quite in the second step. So make sure you guys know PEMDAS here to follow the orders here. So this is how we perform transformation for this case. Okay. So make sure you guys know this. This is very, very important, especially for my next test here. And then we'll talk about the transformation of log later on. So let's talk about this. So the first thing when you guys do for my test or my question here, like number 6 here, is they will ask you for draw the graph of the f of x. So f of x in this case is your parent function, means without transformation. But mostly in my test, I will just call you to draw me this graph. So can someone tell me what kind of transformation do we have for question 6? What is this negative stands for? So your parent function is f of x is 10x. This is the parent function. So if you strip the 10 and the x, you left the negative and the 3. So can someone tell me what is this negative means in transformation? This 3 means.
You have a reflection on the y-axis and you move to the right 3.
Right or left?
To the left. Left.
Yep. Left 3, right? Now, because don't forget positive is the flip. Positive means go left, negative means right. Now, this is a very special case, is because you got the negative and no parentheses. So this is actually wrong. Okay. So what we need to do here is, if you see a negative here with something else, you do need to factor. So this actually, the correct way to do this is 10 to the negative, factor out the negative, and become -3. So every time, this is for calculus. If you're going to calculus 1, if you have a number in front of your x, like -2x plus something, or negative like this, you actually need to factor that number out so that your x in this case is 1x, like computing the square. Remember the second step of computing the square? We want the x squared to be 1, so we factor any number out, negative or 3 or 9 or whatever you have. So this is the same thing when you perform transformation, that if your x here is no longer 1x, you have to factor things out like negative. Now this one is 1x. If you look at number 7, you do not need to factor anything. But once you factor the negative out, this negative is still reflections on the y-axis. But this time, you don't go to the left. This is actually, you go to the right 3. So this is what you guys need to do for my test. And my test, I won't be this tricky where you need to factor the negative out. If I do it, I will do it for you. So that means you do not need to do this extra step. But my main part is make sure you need to tell me what is this symbolize, right, reflection, and so on. So and then once you do this, we will draw the graph. So how do we draw the graph in this case is draw the basic graph, which is 10x. So 10x in this case will be, it will cross at 0, 1. And you just plug x equals to 1. This will be at 10. So this graph is really, really getting very close to your y-axis because, and then if you put 1, -1, this is a 10th. So this is where 1/10, which is 0.1. So this number is really small and it goes really fast like that. Okay, oops, sorry. So this is your f of x, which is 10x. So what you need to do with this is you need to perform your 2 transformation. Now, as I told you, which one do you need to go first? You have to do your PEMDAS. But if you look at these 2 transformation, they all belongs to your exponents, right? So this negative is being multiplied and this 3 is being subtracted. So which one should we do first in this case, since they're all in exponents? So should we do the reflection first, or should we do the right 3 first? Should we do the multiply first, or should we do the add subtract first?
Multiply.
So you need to do the right 3 first. All right, reflection first, sorry. Reflection the y-axis first, then followed by the right 3. So what happens when you reflect this graph on the y-axis? So reflect on the y-axis means left-right interchange. So that this used to be at 10, 1, it will become negative 110. So it's 110 become negative 110. Now this one stays the same because this is 0, 1. When you flip it, it's still going to be 0, 1 because you do not change it. But this will be go to this side. It'll be 1 negative 0.1. So this green line that I draw here is your reflections on the y-axis. And then at the last thing you need to do is you have to move right 3. Now, if this is a graph paper, so what you do is you just take this point and just move right 3. 1, 2, 3. So this is the point when you move 3. Take this point and move 3. 1, 2, 3. So it'll be right here. And then take this point and move 3. You'll be right here. So this graph that I draw, it will be your answer, g of x here. You guys all right here? Can you guys do this in my test? Because this one worth also quite a lot of points, like 8 points, because you have to, tell me what transformation, tell me what is the parent function is, tell me the transformation, and then you have to draw the graph. And once you draw the graph, you get your final graph, you have to tell me what is your domain is, what is your range is, and what is your asymptote is. So that's why it costs a bit more point, because you have to do more. So anyone know what is the domain of this blue graph? Domain is your x value. Anyone?
3.
Domain, can this number reach -1? Can you have -1 for your domain x? Yes, eventually this graph will what? Will cross at -1, right? So how far left do this graph goes? This graph goes to -infinity. And how far right do this graph goes? Positive infinity. So your domain in this case will be what? All real numbers from negative to positive infinity. So class, I want to tell you that all exponents graph, 10x, 3x, I don't care what kind of transformation you perform, left, right, up, down, reflections, your domain is always all real numbers. Okay, so that's fixed. Okay, range. So can someone tell me what is the range of this blue line here? The y value. How far down can it go? This graph is getting closer and closer to what number of the y value?
0.
0 to what? How high does it go? To infinity. And 0 in this case is open because you cannot touch it, because that's your asymptote. So can you tell me what is your asymptote in this case? It's going to be this line, right? Can you tell me what is that equation is? Y equals to 0. Okay, so that is your asymptote for the for this graph. Y equals to 0 means that is your x-axis. So that is how we do this question, and this worth around like 8 points in your test thing around there, because you do quite a lot of work. Okay, and you got 2 of them. One of them is exponents, which we're doing now, and the other one is log, which we will in the next 10-20 minutes we'll talk about that. Okay, well, let's talk about number 7 here. 2 plus 3 EX minus 5. So this is the function here, and the parent function in this case is EX. okay, which is this one. So if you take the EX out from this G of X function, you have quite a little bit of transformation. You got the 2, you got the 3, and you got the -5. So these are your transformation that we have. Okay, and we do not need to factor this because your X is already 1X. So 1X, you're good to go. So now you have to tell me what is this 2 stands for, what is this 3 stands for, and what is this -5 stands for. Anyone? 2? What's this 2 means?
Up to.
This is up to. And remember last time, this 2, I usually put at the back and move it front. Let's talk about this -5. Anyone know what is this -5 is? It's very similar to this one because they're in the exponents, they're in the power. So this one go where?
To the right.
Left.
Don't forget, it's to the right 5, not left, because the polar change. And anyone know what is that 3 in front of it? This 3 is been multiplied.
Is it a vertical stretch?
Yep, this is a vertical stretch. Okay, if this is 1/3, then it would be a vertical shrink. Okay, so can you tell me which one should we perform first? PEMDAS.
To the right, the exponent.
Yep, exponents, because it's exponents. And what's next?
Stretch.
Because that's been multiplied, because there's 3 times of it. And the last one is always go up and down. Okay, so make sure you guys know this. This is very, very important. So now we need to draw the basic graph of EX. Okay, this is a basic graph EX. So it will cross at 0, 1, because when X is 0, is 1. What happens when you plot X is 1? So e to the power of 1. E to the power of 1 is 2.7 something something. So this will be somewhere here. Okay, so e to the power is 2.7 something. If you want to figure out what is 2, you just need to take out your calculator and do e square. E to the power of 2 square is 7.38. So this one will be around 7 point something, 7.4. Okay, if you want to figure out what is the 2. And if you want to figure out what is the -1, you just, do e to the power of -1. Okay. Then you will e to the power of -1. No. Nope. There you go. Sorry, I hit this one is a little bit special. There you go. It's 0.367, so it's somewhere around here. 0. So this is the basic graph of the E. Okay, so this is the EX. So what we need to do with this graph is you have to move it to the right 5. So right 5 means you go this way to the right 5. So there are a few points. So if you have a graph paper, you follow it. So trace it. This one translate. So 5 to the right. 1, 2, 3, 4, 5. So this will be at 5 here. Okay, this will be 0. This one used to be at 2 point something. This will be at here. This will be at 6. Okay, and this one used to be 7.4. It will be over here. This will be at 7. So this graph that I draw is where you move to the right 5. Okay, this is right 5. And now you need to vertical stretch this. What is the meaning when I say vertical stretch? Means you double, or in this case, you triple. So you take all your Y value and you triple it. Okay, you multiply by 3 because you got 3. So this used to be at 1. So 1 times 3, this will become 3. Okay, this one used to be 2 point something. E is what? Let me see. E is this. So you have to triple it and multiply this by 3. So it'll become 8 point something. This will go all the way up to 8 point something. And this one will be like 20 something, even way up there. Okay, so this graph that I draw here, it will be you've been doing a vertical stretch of 3. Okay, and guess what? Your asymptote is still at 0, because when you take this times 3, 0 times 3 is still 0, so it doesn't move it. Okay, so when you do a vertical stretch, your asymptote is still at 0 here. Okay, and the last thing we're going to do is move it up 2. So I'm going to use pink. So when I move up 2 is I have to take all this red point that I have and I move it up 2. So this used to be at 3, so now it will be at 5. Last time this used to be at what, 8 point something, right? Now it's going to be 10.15. So this will be at 10.15. And don't forget, now this used to be originally at 0. Once you move up 2, your asymptote will also move up 2. This is very important. A lot of students forget the asymptote, because the asymptote actually will determine, you cannot cross it. So that's the reason why that a lot of students make this graph wrong, is because they will do something like this. You move up 2 and you go crossing down here, and that will be wrong. Because your graph cannot cross your horizontal asymptote. So that's the reason why that your graph in this case will look something like this, sorry, and it will cross something like that. You know what I'm drawing here, because it's hard to draw freehand. So you look something like this, but this the horizontal asymptote plays an important role. It's telling us that you cannot cross that line. And what determines it? Him. Okay. So, so by looking at this pink line, can you tell me what is your domain, range, and your asymptote in this case? What do I tell you about exponents? What is the domain for any exponents that you have?
All real numbers.
So I don't care if it's EX, 3X, 10X, it's all real numbers. Range, now range you have to watch for carefully. So what is the lowest Y value you can have?
2.
2, and it goes to where?
Infinity.
So this 2 is determined by because you move up 2. So this 2 is the one that makes you change your range. And your horizontal asymptote is Y equals to 2, and again is because you move up 2. Okay. So, so this is how you do this kind of questions in my test, which costs around like 7, 8 points. So make sure you guys know how the transformation works and what's the domain and range and asymptotes in this case. Anyone have any questions for me?
For the test, do you want us to put down all the graphs, like the
No,
purple ones?
in the test, I just want you to give me 2 graphs. I mean, if you do all the graph, it's fine. But if you have a pencil, it's all going to be one color, right? So I recommend you, I only need 2 graphs. I just need the original graph, which is this fellow, and I need the final graph, which is the pink one. Okay, same thing happens on the other side. I need the original graph, which is the f of x, the black one, and I need the blue one because that is your final graph g of x. So in your test, I need 2 lines. One line is the original, is ex or 10x or 2x, depends on the question, and then the last one is g of x, which is the last function. But if you draw extra line like what I did here, then if they are all the same color because you're using black, so then I will recommend you to fuzzy it. So once you fuzzy the line, then I know that is your final answer. Okay, so you just make it a bit of fuzzy in this case, because then I can tell. If you have a colored pencil or if you have colored pens, be my guest to do what I just did here, because then you see very clearly all the different colors. But if you don't have a colored pencil or colored pens, then I will recommend you to fuzzy the line to tell me that is your final answer. That's your g of x function. Anyone questions?
Do we have to graph the asymptotes as well?
Yes, because the asymptote will, because you cannot cross the asymptote, so the asymptote is where it's needed. Okay, because once we want to figure out, a lot of students don't graph the asymptote and the line will go below it, and you won't get full points there.
Okay, thank you.
Good. You guys got a question now? Yes. Okay, so now we're going to talk about log. So this is the exponents that we talk about. So now we will talk about log here. So log function is actually what we call as an inverse function of an exponent. Okay, so so what is an inverse function? We talk about that on chapter 2.6. In order for you to have an inverse function, it has to pass the horizontal line test. Means that every time when you draw a horizontal line, it has to cross at one side, at one point. You can tell by the graph of exponents. This is the graph of exponents, right, that we draw on 5.1. No matter it's exponent growth or exponent decay, you find out that they pass the horizontal line test, means they're 1 to 1. Okay, you cross, you got 1 point. So the exponents is actually log. If you do the inverse of exponents, is log. So ax is what we have last time with the base is a. So if you want to draw, if you want to find what is the inverse of ax, is log ax. Okay, where the a in this case is in the bottom of the log, so it's a little bit tiny. That is called the base also. Okay, so this is also a base, so that is a base a. And x in this case is called an argument. Okay, so in this case, your a is called a base, and x in this case is called your argument. Okay, now if you have log function, your domain in this case is x has to be greater than 0. Okay, so when you have a log function, the domain is always whatever inside your argument, the x has to be greater than 0. For example, is if I give you log x plus 1, can you tell me what is your domain in this case? If I give you this, what's the domain for this? So what you do is you take what is inside the parentheses, x plus 1, and you make it greater than 0. And you solve for x. You guys know how to solve for x here? So x in this case is what? Greater than -1. Or in other words, -1 to infinity. You guys all right here? Anyone? Let me give you another one. Can someone tell me what is your domain for this case? Log 2 minus 5x.
-2/5.
Is that x is greater than or less than?
Less than?
Yes, x is less than 2/5 in this case. Because when you divide by -5, what happens to your inequality is you have to switch it around. So that's why your domain in this case will be x is less than less than 2/5. So what is the meaning of this is that when I say, when I say your domain is, when I tell you your domain is x has to be greater than -1, means that your graph, this is your -1, which is your vertical asymptote, means your graph is somewhere here. Okay, that means you cannot cross to the left side. And when I say the domain is x is less than 2/5, means that at 2/5, this is your, again, your vertical asymptote, less than means, that means your graph is on this side. Okay, so if I see any graph, only lines drawing on the other side, I know it's going to be wrong. Okay, so that's how you figure out your domain in this case. Very important. And it's very easy to find. It's not that difficult. Okay, we'll do how we change base here is you can always change base by moving your log, your base, move your base. Okay, so if you want to change from log to exponents and exponents to log, you just move your base. For example, in this case is if you have 2 is equals to log 39. And if you want to write this is log. So if you want to write this in exponents, you take your base and you move it up. And then you drop your log. So in this case, it will be 3 squared is equals to 9. So if you want to write your log to exponents, this is what we call move your base. And if you want to write the other way, it means from exponents back to log here. Again, you take your base and you move it down. So this will give you 2 log 39. Okay, so this is how we move base. This is very important. This is what we call as log to exponents and exponents to log. So if you want to interchange, log to exponent log, we move your base here. Okay. This is something extra here. If you have just log by itself, it's called the common log. That means your base is 10. So if you look at your calculator have log symbol here. Okay, all your calculator have log symbol. This log symbol is called the common log, means the base is 10. So if I give you 3 is equals to log 100, 1,000. So what you do is, if I want you to write this in exponents, this is actually base 10. Okay, they don't write the base, but it's automatically base 10. What you do is, if I want you to write exponents, you move your base. So you will get 10 to the power of 3 equals to 1,000. Okay, so when you have log by itself, like this fellow, it is base 10. And then I will tell you a little bit of the natural log. So if you have natural log is called ln. It is log base e. That means that ex has an inverse function, and that inverse function is natural log, which is called ln. Okay. So example in this case is if I say x in this case is ln 5. And if I want you to change it back to exponents, you can move this base, and the base in this case is e. Okay, so you will get ex equals to 5. So don't forget ln, if you want to move the base is e. Log, the base is 10. Okay, so in your calculator, you will have these two, log and ln. Okay. So log and ln is for those two. Okay, so let's do some example first, and then we talk about the properties. Okay, so the first example is want us to write this into exponents form. So it's like a move your base here. So can someone tell me how you write question 1 from log to exponents? Move your base. That's what we did over here. Anyone?
9 to the power of -2
Equals to?
1/81.
Yep, that's it. Okay, very easy. And we are not solving this equation. Don't try to solve it or don't try to prove it. We're just going to write it. How about question 2? How we write this natural log into exponent form?
E to the power of -0.693 equals 1/2.
We should put a dot in here, and this is equals to 1/2. Yep. And you can write the other way, which is 1/2 equals to e to the -0.693 ... So don't forget, you can interchange this, doesn't matter. It's very easy. This one is, but it's important. Next, you do the opposite. Now I give you the exponents form. You have to write your answer in log form. So again, move your base. Anyone?
3/2 equals log 9/27.
Okay, and make sure this 9 is a small 9 in the subset. Okay, and I will show it to you how you do it in your online homework, how you type all this. And how about 4? Move the E over and you get what? Anyone? This is easy, but you get what?
2x equals ln 3.
Yep, that's correct. And we are not solving. Please don't solve for x. Just leave it like this. So this is very important when you go to 5.4 when we solve equations. So this is called change from log to exponents or exponents to log, or another word says move your base. Okay. Now there are some properties of log. The first property is log 1 is always 0. Okay, so I don't care what base you have. It can be base E, base 10, ln1 is 0 too. So this is the first one, is anything with 1 is 0. The reason why is because if you move the base a to the power of 0 is 1. This is what we figure out from exponents, right? If you do log AA, that means your base and your argument is exactly the same number. You will get 1. Because when you move the a to the power, you get a1 equals to a. So that's why log AA is 1. So in this case, if your base and your argument is the same, it's 1. Moreover, this is very special. When you have log AAX, so that means your base and your argument is the same, but your argument has a power of x, that x is your answer in this case. Okay. The reason why is because a log ax is equal to x, and this is called an inverse property. And the last one is called a 1-to-1 property. If you have equation and the log are the same base, then the argument is also equal to each other. So this is usually, the last one is used a lot when you want to solve log equation with same base. That means your base is the same. Okay, so if you try to solve some log equation that having the same base, we will use him. That means you just put the argument become the same here. Okay, so we will do some of these properties here. Same thing with the ln. Okay, so question number 5. Figure out what is this is. So for question number 5, is given us by x is 1. So if you plot x equals to 1 here, you will get log 8, 1. Okay, my x is 1. So can someone tell me what is log 8, 1 is? Without using a calculator.
0.
Yep, 0. So as long as your argument is 1, it's always 0. Okay. Next, question 6 is log ax, where x is a squared. So now I replace the x is a squared. So what we're gonna have here is, write 6 over here. Log a, and the x become a squared. So does anyone know what is log a squared?
X2.
Just 2, yep. Okay, so in other words, the log a will cancel each other out. How about question number 7? ln x, where x is e to the negative 5, 6. So when you plug x to become e to the negative 5, 6, what you guys got? Don't forget, ln is base e, right? And what happens to the e and e here? They cancel out like number 6. So you get what here?
Negative 5, 6.
Negative 5, 6. Okay. And the last one, number 8, this one is a little bit tough. It's given us log 25x, where x is 5. So we will get log 25, 5, because our x in this case is 5. So how do we do this is, if you remember, we will try our best to make your argument and your base the same. Because if they are the same, you can cancel it and then you take whatever the exponent is your answer. So what we're going to try to do here is we try to rewrite this so that this 5 is 25 to the power of something. And the reason why we want to write this is because then the 25 and 25 can cancel. So this power will be our answer in this case. So can someone tell me 25 to the power of what give us 5? See how many of you can do this. 25 to the, so in other words, 25 to the power of what is 5?
-5.
No.
1 or 1/2.
1/2, yes. So do not forget that square roots can be written down as a power, and the power is 1/2. Okay. If you have a cube root, it can be written down as a power of 1/3. Okay. So when your power is a fraction, your denominator is the index of your root. So this is actually is 1/2. So to write this is actually is 25 to the power of 1/2, which can someone tell me what is log 25, 25, 1/2? This will cancel out. So what you get is what?
1/2.
So make sure you guys know a little bit of exponents rules here, or exponents root. So you can write root in the exponents form. So that's how we do this kind of questions. Okay. Anyone have any questions for me with this?
Yeah, could you explain number 6 a little more?
Yeah. Number 6 is where you put a square into your x. So you got log a square. As long as your argument and your base is the same, they can cancel out and you got 2. There is a property for it, which is up here. Log AAX is x.
So does that work with like other numbers?
Yes, as long as your base and your argument is the same. Yes, with a log in front.
Okay.
But for the E, make sure then it's ln and E, because the base is E. If you have log, then the base is 10. So if I call you to what is log 10, 3, what is your answer in this case?
3.
It'll be 3, yep. Because the log and the 10, because this is the base 10. You guys all right here? Let's give you a few examples. We're gonna solve this equation. In order for you to solve equation, as long as they are the same base, you make the argument the same. So in this case, since these two are having the same base, they are base 10, then you just take 2x plus 1 is equals to 15. And you solve for x. It's very easy. Okay, so this chapter, the 5.1 and 5.2 is not tough, because you can tell that, oh, this is, you guys want to solve for x, right? Anyone solve for x for number 9?
6.
6? I don't think so. 6.
Oh, sorry, 7.
7, right? Okay. So as long as it's the same thing with here, the ln, the same base, the base is E. So what you do here is x squared minus 2 is equals to 23, and you solve for x here. Okay. You move that 2 over, become 25, and then don't forget, every time when you take a square root, what do you need? You did it in my connect section. How many answers you have?
2.
2. So you need the plus and minus. So your answer is what? plus and minus 5. So this is your solving equations. So we want to make them the same base so you can cancel them out. So the last thing, which is the most difficult one, so far everything is pretty easy, right? So I can do this. The difficult part is the graphing piece. So we're gonna talk about the graphing piece. So we're gonna talk how you draw a graph here. So this is the most difficult part, and then we're gonna use transformation to label your graphing here. So in order for us to graph log AX, where A in this case is greater than 1, I'm going to use 2 because it will make a little bit easier for us to do. Okay. So how do we do this is, again, we need the table. And we need XY. Oh, sorry, we need the graph. We got a table here. We need the graph. Okay, so we know that you cannot put negative number in X. The reason why you cannot put negative number is because your domain is a positive. Okay, so this will not work. Okay, so there's no, you cannot put negative number. You cannot also put 0 because this will give us an error. So it's very easy for you to figure out is if you take out your calculator and you do like log of log 0, you will give you an error. And if you do like a negative number, I don't care what number is it, negative 0.5, and if you do a log or ln, you also get an invalid input. So that means that your X in this case only can be positive, cannot be negative, cannot be 0. And you learn already what happens if this is 1, right? Can someone tell me what happens when you do log 2, 1? We got a property for it. Log 2, 1 is what?
1.
No.
0.
0. Okay, don't forget, if your argument is 1, you get always 0. That's your first property. Now, we want to make this X the same base as 2. So we will use 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, and so on. The reason why we do that is because the 2 and the 2 can cancel. So can someone tell me what is log 2 to the power of 1?
1.
And what is log 2 to the power of 2?
2.
And 2 to the power of 3?
3.
And 4, right? Can you tell me what is 2 to the power of 1? That is 2, right? Can you tell me what is 2 to the power of 2? 4, right? 2 times 2 is 4. 2 to the power of 3, anyone?
8.
And 16,
16.
right? Now I'm going to erase a little bit because I don't have to move. So this is the log 2 here. So we're going to do a little bit here. So when you do 1, you get 0. When you get 2, you will get 1. The next one we have is when you do 4, you will get 2. And when you do 8, this will get 3. Now, you cannot 0, cannot have negative. So all this you cannot have. So a lot of my students in my test, they do something like this, and that is wrong because what happens to this side, the one that is between 0 and 1 here, it will what? Go down. And this will be parallel to this vertical asymptote, means this fellow will not cross it. So this is log 2x. So can someone tell me what happens if I want you to draw log 3x? So we still use negative, no good. 0, no good. So we can still use 1. So we can still use him. Oops, sorry. And when you put 1 into here, you will still get 0. So for log 3x, you still get the 1, 0 here. But we cannot use 2, 1, 2, 2, 2, 3, 2, 4 here because your base is not 2, your base is 3. So now this is all changed into what? The base is 3. So you still get 1, 2, 3, 4, but your answer here is not 2, 4, 8, 16. So this will be 3. So at 3, you will get 1. 3 squared is 9, right? So at 9, you will get 2. And then this one is even worse. So again, a lot of students draw your graph something like this, and don't draw me like that, because this fellow will get closer and closer to your y-axis. Okay. So the blue graph is the log 3x. So what can you tell me between log 2x and log 3x? If you look at the graph here, this is getting what? Closer and closer towards what?
Exactly.
The x value. So if I want you to draw what is log x, that means the base is 10. So it's still gonna be 1, 0. But now the next one we have is gonna be 10, and you get 1. So this graph, which is very close to the to your x-axis here, is your log x. Okay. And what happens if I want you to do the ln x? Now we know that ln means it belongs to the e, and e, the base is e, and e is 2.7 something something. So we know log 2 is the orange one, log 3 is the blue one. So ln x is going to be log 2.7 something something. So it will be going to be this red one, and it's still going to cross at this 1, 0, and it will go down here. So that means that the ln x is going to be in between log 2 and log 3x, more towards log 3x, where 2.7 something, you will get exactly 1. Okay, because 2.7 is e to the power of 1. So that's why you will get that. So those graph that I show it to you is the log graph. Okay, you guys all right here? Anyone? Questions with this log graph? Now let's talk about domain and range. Your domain in this case is the x value. So no matter all this graph that you draw, it will not cross over at here, right? Cannot. So your domain in this case will be from 0 to infinity. Or as I mentioned, x is greater than 0. You take your argument x and make it greater than 0. Your range, because this one goes to negative infinity and this one goes to positive infinity, your range in this case is all real numbers. Okay. The asymptote in this case is gonna be x equals to 0 because it is a vertical asymptote. Okay. So if I want you to compare between log 2x and 2x, the one is log, one is log. So log 2x, if I draw it out, it looks something like this, like the one that I draw, the orange one. This will be at 1, at 2, this will be at 1, at 4, this will be at 2, something like that, right? And if I want you to draw 2x, 2x will look something like this. It will be at 0, 1, 1 will be at 2, 2 will be at 4. So this graph, the purple graph, is 2x. What do you notice about this? Because we are inverse, log 2x and 2x inverse, you notice that your coordinates is switched around. So when you look at this coordinates is 1, 0. And when you switch around with 0, 1, this is 0, 1. Do you see that? And if you look at another coordinates, this coordinates is 2, 1, right? Because x is 2, y is 1. And if you look at the 2x, the inverse is 1, 2. So what can you tell here is that your coordinates is all been switched around. This is 4, 2, this fellow. And then this one is 2, 4. So this is first thing that you need to know. All your coordinates for the inverse, they switch around. So if you know how to draw 2x, you should know how to draw log 2x. You just switch your xy around. And another thing is, if you draw the y equals to x, which is this dotted line, you notice that this 2 graph is the reflection. That kind of like, if you fold it right in that y equals to x, they kind of coincide. Okay. And the domain and range is flipped. If you remember this on my first task, if you look at this, the domain in this case, which is this one, right? Which is we just did here. So the domain for this is all 0 to infinity. The range in this case is all real numbers. But if you look at the purple one, your domain in this case is all real numbers, which I told you for all exponents is all real numbers. And your range in this case will be 0 to infinity because it's start from 0, cannot touch 0 and go infinity. So what you notice about this is they are literally switched also. So your domain is the same as your range, and your range is the same as domain. This is what we guys did in your 2.6 when you talk about domain and range. So so this is fixed. So as I told you, right, when you do exponents, your domain is always all real numbers, no matter how you transform it. Your range is also going to be all real numbers, no matter how you transform it. Okay, so this is fixed. The domain, this is the one that is changeable because it depends on your transformation. Okay, so this is your the log graph that you guys need to know, and then I'll show you what is a transformation means here. So anyone have any questions for me here? And now we talk about transformation. Okay, so again, we got the up down, remember that one? So let's say now we are doing log ax, and our a in this case is, let's say, 5. Okay, again, it can be any variable we want for a number we want for a. So in order for us to figure out if they are going up, what you do here is you get this y function and then you add like k. Okay, example is gx equals to log 5x plus 3. So you have this means you go up 3. Okay, if you go down 3 means that you minus k. So, and again, it can be tricky. I can write this as 3 plus log 5x. They are the same thing. Okay. For this one, I will do log 2x minus 4. Again, class, this base can be 2, can be 5, can be anything. It's not a part of your transformation. It's a part of your basic graph. Also can be written down as -4 plus log 2x. Doesn't matter how they write, it's the same thing. Okay, so this is up and down. And then remember, we can also move left and right, right? So in order for you to move left and right, left, let's say, then you will have a plus k inside your parentheses. Example in this case is log 5x plus 3 in a parenthesis. So you see the difference here now? So no parentheses means you go up or down. With a parenthesis, that number inside means you go left and right. And for the right case, you put a minus sign. So it will be log 2x minus 1, something like that. You guys all right here with the up, down, left, right transformation? This is important. Again, we have a reflections on the x-axis. Reflection on the x-axis means you put a negative in front of the log. For example, in this case, it will be negative ln x, okay, or negative log 5x or something else. Don't forget that the log graph is this, or the LN graph is like this, where you intercept this at 1. So what happens when you do a reflection on the x-axis? So this is your x-axis. So you flip up and down. So this one go down, it will go up. And it's still going to be at 0. And then this will, and this is up, you'll flip down. So this orange line is the reflection on the x-axis if you have the green line. Okay. We can also do reflections on the y-axis where your negative is inside the log, okay, or ln. Example in this case is ln negative x or log negative x. So if you have such things, then you will have a reflections on the y-axis. So how do your reflections on the y-axis if you go back to your original? Don't forget your green line is your original graph. So if you reflect this on the y-axis, it goes to the right. So when you reflect it, it will go to the left. And since it will intercept here at 1, this will become -1. So this is a reflections of the y-axis. And as usually, we can have both. So when you have both, means you have a negative and another negative in and out. So for example, when you do both, is a negative and a negative. So if you have something like this, it's both. And how do we do both in this case? Is you got the reflection on the y. So you just need to reflect this on the x. So this one will go like this. So the red one is where you will have both reflection, or you can take the orange one and then flip it on the other side. And the red line is where you will have reflections on x and y. You guys all right? Very similar, but and then we got the vertical stretch and vertical strength. This is where you multiply it with a number, let's say b, okay, to the y. And this b has to be greater than 1. For example, 3 log x. Okay, so if you multiply this with a 3, it's a vertical stretch. And then we got the vertical compress or vertical shrink. It's going to be where your b is in between 0 and 1. So that means like 1/2 or 1/3, something like that. Okay, so this will be your vertical stretch and vertical compress. And then we have the horizontal one. So these are everything we have. It's horizontal stretch. It's the same thing, but this time your b is inside your log. Okay, so it means we multiply. Again, you flip this, so your b is between 0 and 1. So example will be like ln of 1/5 x. So if your multiplier here is between 0 and 1, then it will be what we call as a horizontal stretch. And we have a horizontal compress, then your b will be greater than 1. So make sure it's inside your function, your log function, so like 5x like that. So that will be a horizontal compress here. Again, which one we do follow orders of operation, PEMDAS. Okay, same thing, orders. So very similar to exactly the same transformation that we have for exponents, but now it's log or ln. So a little bit different, but you can kind of relate a little bit. So so I'm going to do transformation of log here. So again, these are all going to be in, I will send it to you guys. So so you guys can refer to it. So now what we're going to do here is we're going to take I'm going to take attendance. Take attendance here. Go ahead and do present in my. So we're going to talk about, I'm going to change question 11. So a bit more difficult. This is, I want you to graph gx equals to 5 plus ln 2x minus 6. I just changed number 11 to this, which you have to draw the graph, and then after that, figure out the domain, intercept, and a transformation. So again, you need to figure out what is your parent function is, or your original, or your basic graph. Last time, remember, it's 2 to the x, or 3 to the x, or e to the x. So this time, this will be lnx. Okay, so you should strip your ln and x. That will be our transformation in this case. Our basic lnx is our basic graph. So the leftover is a transformation. Now, as you remember last time that we own your x has to be 1. This x is 2, so you need to factor him out. So what you need to do here is, because our x always needs to be 1. Again, this is not going to in your test. This is what you will see in calculus class. So you actually have to factor the 2 out. Do you know what happens when you factor the 2 out? From 2x minus 6, you get what? You get x minus 3. So we got a few transformation here. We got the 5, we got the 2, and we got the minus 3. So can someone tell me which one should we do first? What transformation is we have here? What does this 5 means? Anyone? Two, 3, 5 here means
5.
You move up 5. Yep. How about this 3 on the parentheses here? What does that mean? You move to the right 3. Anyone know what is this 2 stands for? This one has been multiplied. Anyone?
Vertical stretch.
It's a horizontal because it's inside. So it's going to be horizontal compress. Okay. So vertical stretch and horizontal compress is kind of like opposite to each other. So the only thing is they're inside. Okay. So it's a horizontal compress. So which one should we start to do first here? Up 5, the compress, or the right 3?
Right 3.
Okay, I know that a lot of people follow orders of operation. You just look inside. Oh, this is inside of the parentheses. So we do him first. But actually, if you look at this whole thing is actually treated as 1. So actually, you have to do the horizontal compress first. Means this is multiply before you do the right 3. Then the up is always the last one, up 5. Okay, so when you have horizontal compress, you have to do that first before you perform left or right. So lnx is your basic graph. So lnx always intercept at 0, 1 here, 1, 0 here. The next one is going to be e. E in this case is 2.7 something. You will get 1. Okay. If you want to continue doing this, the next one is e square. Where is e square? E square is 7.4. So the next one we have is around 7.4. This is e square, and you will get 2. So this is your basic E graph. And don't forget, it's not just hanging on the top half of the graph. It goes down here, okay? And your asymptote is right here. The vertical asymptote is right here, okay? Without the transformation. So now what you need to do here is you have to do what we call as a horizontal compress. So when you do horizontal compress, your X value will be dividing by 2. Okay, so a compress means we divide horizontal, we divide vertical, stretch or compress, we multiply. So in this case, that all this value will be shrink, will be compressed into half. So this used to be at 1, now it will be at half. 2.7, if you divide by 2, this is 1.35, so it's going to be close to here. So this number here is 1.35, means you have to cut all these numbers by half. So 7.4 divided by 2 is around 3.7, so it's around here. So this graph, the rate graph that I draw now is the horizontal compress, and this is half. Okay, so everything that we have on the x value here is going to divide by 2. Okay, and your vertical asymptote when you do is 0, and when you divide by 2 is still 0, so it won't affect your vertical asymptote. And then we're going to move right 3. So move right 3 means we're going to move all these rate points. We have the 3 rate points, right 3. So 1/2, when you move right 3, this will become 3/2. So this is your point here. This will be 3.5. Okay, this used to be 1.3. When you move right to the 3, 1.3 will become 4.3. So somewhere here. Okay. This one used to be 3.7, you become 6.8 somewhere here. So this this purple is your when you move right 3, but don't forget, because it is on x equals to 0, when you move right 3, it will affect it. That means that this graph will move, your horizontal asymptote will be moved right 3. So that means that your graph of the log here cannot cross this purple line. So this will look something like this. So this purple line is where you move right through. So your asymptotes has to move with it. Okay. And the last one is you go up 5. So you just take all this purple point. This is 3.5 at 0. You move it up 5 here. So this will be somewhere here. This will be at 1, so you'll be at 6. And this one used to be at 2, this will be at 7. So this graph is your answer in this case. And yes, it will keep on parallel to this one. So this is your g of x here, which is 5 plus ln 2x minus 6. When you move up 5, you move up 5, you still get back the same 3, because moving up and down won't affect your vertical asymptote. So by looking at this or a green line, can you tell me what is your domain, your range, and your asymptote? So domain in this case is what? Because of this line, you cannot cross, so it goes from what? 3 to infinity. If you do not know this, you can always take this, remember the first 1 and 2 log, and make it equals to 0. Remember we did that the first time, okay, on here. Okay, we make, now remember this one and make the domain. So you can do that too. You can take this equals and solve for x. And your x in this case is x is greater than 3, which is 3 to infinity. So that's why you can do it that way too. If you doesn't know how to do a graph or something else. Anyone know what is the range here for the green line? It's gonna be all real numbers. So no matter what is your no matter how you transform this, your range is all real numbers for log or ln. And your asymptotes in this case will be this line, x equals to 3. And again, class, if you doesn't know how to draw this graph, you can also find it from when you solve for your domain. That means that 3 that you find is your asymptote in this case. So this is how you do graph this kind of equation for ln. So as I mentioned that this worth like what 10 points, 8 points in your test. You will have two. One is for exponents and one is for log. So make sure you practice this. So so we're gonna end today's class here. So make sure you try to do number 12, which I did not do. Negative log 4, this one. Yep, number 12 here. So I will go through this on Monday class with you guys. Your online homework. So you got 3 online homework due this coming Wednesday. So first 4.1 and 4.2, 4.3 and 4.4 is due on the tonight. Okay, so it's due tonight. Okay, and then there are 3 homework due on next Wednesday. 5.1, 5.2, and 5.3. This is due on next Wednesday. So we did already 5.1 and 5.2. So we will finish up 5.3 on Monday. So make sure that you got 3 homework due on Wednesday, this next coming Wednesday, and 2 homework due tonight. So if you have any questions, please let me know. So we're gonna end today's class here. Anyone have any questions for me? You may stay. If you have no questions, you may go.